Hey gang, going to look at a few more examples here with probability. So here we have one card is drawn from a well-shuffled deck of 52 playing cards. What is the probability that it is either an ace or a red card? I'm just going to bring up a calculator as well here. So an ace or a red card. Well, remember there are 52 cards in a deck. Of those 52, 26 of them are red. So 26 out of the 52 are red, and every suit has an ace, so there are 4 aces. So at first glance you might think that the probability is 30 out of 52. Okay? However, you would be counting the ace of hearts and the ace of diamonds as an ace and as a red card, so you'd be counting them twice. So technically, we have 26 red cards, and 2 of the aces are already included, so we just need to add on the other 2 aces. So our probability would be 28 out of 52. Okay? Another way of thinking about that is we're taking the number of red cards plus the number of aces. Okay? So this is the probability of a red card plus the probability of an ace, and then we would subtract the probability of a red ace, which there are 2 red aces. Okay? The reason we would subtract that is because we've added it in twice. Okay, so we've already counted it once here, and then we counted it again here, so we need to subtract it over here. So if you look at that, 26 plus 4 is 30, minus 2 is 28. So we do get 28 out of 52. Okay. We're not going to worry right now about what disjoint means. We are going to think about independent, though. So are the events the card is red and the card is an ace independent? What that means is if you think about coin flips, okay, you flip a coin once, then you flip a coin a second time. The second time, it doesn't matter what you flip the first time. It's not going to influence the probability of what comes up the second time. So independent is the same thing here. The card is red. Does knowing that the card is red change the probability that the card is an ace? Okay, and it doesn't. Okay, if the card is red, there's a 2. Actually, let's do it the other way. If the card is an ace, there's a 2 in 4 chance that it's red. So a 50-50 chance. Well, if the card's not an ace, or if it's just any card, there's also a 50-50 chance. So we say that that's independent if the probability doesn't change given that extra information. Okay, so the card is red, the card is an ace. Those are independent events. And then let's look at number 12. What is the probability it is a red face card? So a face card is a jack, queen, king. They're over here. And so we can see the red face cards are in this column and this column. So we have 6 red face cards out of 52 total cards. So our probability would be 6 out of 52. All right, let's look at a couple more examples here. 2 bags, A and B, contain colored balls. Bag A has 3 red balls and 5 green balls. Bag B contains 6 red balls and 4 green balls. A fair coin is flipped to determine which bag to draw a ball from. If heads is flipped, bag A is selected. If tails, bag B is selected. What is the probability that a red ball is selected? So I'm going to show you one possibility here for a visual that can help you solve probability problems. We're going to use a tree diagram. So we're flipping a coin. So when you flip a coin, there are 2 possibilities: heads and tails. And each one of those has a probability of 1/2. After we flip the coin, if it's heads, bag A is selected. And we're going to have red and green balls in bag A. Okay, so we're basically bag A. And if bag A is selected, there are 3 red and 5 green. So 3 out of the 8 are red, 5 out of the 8 are green. If tails is flipped, then bag B is selected. And in bag B, we also have red and green. In bag B, there are 6 red and 4 green. So 6 out of the 10 are red, and 4 out of the 10 are green. Okay. We want to know what is the probability that a red ball is selected. So we want to know here a red ball is selected, and here a red ball is selected. We don't really care about the other two situations. And what we do with the tree diagram is we multiply probabilities along the branches. So we would multiply 1/2 times 3/8. So 1 times 3 is 3. 2 times 8 is 16. So the probability that we flip a heads and draw a red is 3 out of 16. Remember we said when you've got and, that means you're multiplying your probabilities together. Down here, if we flip tails, that's 1/2, and then a red, that's 6 out of 10. So 1/2 times 6 out of 10. 1 times 6 is 6. 2 times 10 is 20. So 6 out of 20. So now we've got two probabilities. Well, what do we do with these two probabilities? Well, all we care about is that it's red. So we want to know this is the probability, 3/16, that we got a red ball from bag A, or we could have got a red ball from bag B. Remember, or, we're going to add up the probabilities. So we want to add 3/16 plus 6/20. Okay? Plus 6/20. And we get 3 divided by 16 plus 6 divided by 20.4875. So there's a 0.4875 chance of selecting a red ball. Now, something else that I want to show you here too. If we did multiply these out, 1/2 times 5/8, 1 times 5 is 5, 2 times 8 is 16, and down here 1/2 times 4/10, 1 times 4 is 4, 2 times 10 is 20. And now if we add all of these up at the end, 3/16 plus 5/16 is 8/16, which is 1/2. 6/20 plus 4/20 is 10/20, which is 1/2. And 1/2 plus 1/2 is 1. Your probabilities at the end always have to add up to 1. Okay? Individual probabilities also always have to be between 0 and 1. 0 means it's never going to happen. 1 means it always happens. So you can't be more than 1. You can't be greater than it always happening. And you can't be less than 0, less than it never happening. Okay? So these probabilities at the end of your tree diagram, they add up to 1. Alright, let's look at number 14. A fair die is rolled to determine which bag to draw a ball from. If a 1 or 2 is rolled, bag A is selected, otherwise bag B is selected. What is the probability that a red ball is selected? Alright, this time I'm going to show you something called an area model. Okay. So an area model, we would be rolling a die. So if it's a 1 or a 2, we're going to be selecting from bag A. Okay, so that means there's a 2 out of 6 chance that we'll be selecting from bag A, and a 4 out of 6 chance we'll be selecting from bag B. Each of those bags has red and green balls in them. Okay, now for bag A, that has 3 red and 5 green, so 3/8 or 5/8. For bag B, though, I'm going to have to put this down here because it's a little bit different. For bag B, it has 6 red and 4 green, so 6 out of the 10 are red, 4 out of the 10 are green. Okay. Now we want to know the probability that a red ball is selected. So a red ball would be one of these two boxes on the left. So those are the only two we need to worry about. And what we're basically thinking about here is finding the area of this box. And to find the area, you take length times width, or base times height. So we have 2/6 times 3/8. So 2 times 3 is 6. 6 times 8 is 48. We can do the same thing down here. 4 sixths times 6 tenths. 4 times 6 is 24. 6 times 10 is 60. Okay. And we could reduce those. 6 out of 48 is 1/8. 24 out of 60 are both divisible by 12, so that would be 2/5. And now we want to add up those areas, because we don't care. It could be bag A or bag B, but we just want a red ball. So 1/8 plus 2/5, 1 divided by 8 plus 2 divided by 5, 0.525. Okay. So this time there's a 0.525 probability of getting a red ball. We could multiply out the greens as well, and we would find that if we added up all the stuff inside, it equals 1. It has to equal 1. Okay? Alright, so that's going to wrap up our second video for probability.